All right, 7.EE.4 goal number 2. This is video number 4, and this is going over multiplication and division properties of inequalities. The materials you need for this is your MISSIN and those inequality notes that you started in the last video. So, you're going to be writing these first bit of notes on the second flap if you made flaps. If you didn't, you will be writing them just on the next couple of lines. So here we go, inequality notes. So the whole concept behind this is what should you do if you see a multiplication and division problem? When you multiply and divide an inequality by the same positive number, the inequality remains true. So we have the problem 8c is less than or equal to 40. So the first thing that we can do, we know that if we have something that says 8c is less than or equal to 40, if we were to just look at this as an equal sign, we know that we could just divide by 8 on both sides. We are essentially dividing an inequality by the same positive number, so divide by 8 on both sides, and we get just simply c is less than or equal to 40 divided by 8 is 5. So c is less than or equal to 5. So if we tried out like the number 4 for c, c is equal to 4. 4 is less than or equal to 5, so 8 times 4 is 32. And is 32 less than or equal to 40? Yep, sirree, it is. Let's try the next one. We have 3/4 n, and actually I'm going to give myself a little bit of room. We have 3/4 n is greater than or equal to 15. So we are going to start out with that same idea of making our line so we can see maybe, or we cannot pay attention to that equal sign. And we have 3/4 times n is greater than or equal to 15. Now we can deal with this 3/4 in a couple of different ways. We could possibly divide by 3/4, or we could do the quick and easy step of multiplying by 4/3, the reciprocal, multiplying by its opposite. Either one works. Let's start out by just dividing by 3/4 and seeing why we could essentially have multiplied by the reciprocal. So we'd end up with n is greater than or equal to 15 divided by 3/4. Let's rewrite 15 as a fraction, so that's a little bit easier to deal with, 15 over 1. So 15 over 1 divided by 3/4, we can essentially rewrite that as n is greater than or equal to 15 over 1 times 4/3. From there, let's do a cross simplification. We know 15 has a 3 in it and 3 has a 3 in it, so we could rewrite this as 5 and rewrite that as 1. So let's multiply straight across. After that, 5 times 4 is 20 over 1, which is just simply 20. N is greater than or equal to 20. So if we tried 21 in this case, or if we tried 24 in this case, let's maybe try 24. That seems like a nice, easy number to work with because I see a 4 in this denominator. So if we did 24, essentially 3/4 of 24. 3/4 of 24 is 3 over 4 times 24 over 4, or over 1. Let's do that simplification. 4 divide 4 out of both of those, we get 1 and 6. 3 times 6 is 18. So 18, is that greater than or equal to 15? It sure is. So this n is greater than or equal to 20 works. So now it looks like I'm going to be bleeding onto my next page, so I'm going to actually erase this just so it doesn't get crazy when I look at our next missing page. Let's try a couple of problems that relate to this concept. And let's see how that goes. So here is our couple of problems. I want you to first do these and then I will go over them. So please pause this video. We have h divided by 7 is greater than or equal to 3. So please pause the video and do that problem. And then do the problem 2/3 n is less than 20. Okay, so when you've restarted the video, here we go. We have h divided by 7 is greater than or equal to 3. Essentially what we can be doing is we can multiply by 7. Multiply both sides by 7 because h is being divided by 7. What undoes that division of 7? Well, we could multiply by 7. That undoes division. Multiplication undoes division. So we simply have h is greater than or equal to 3 times 7, which is 21. So we need a number that is greater than or equal to 21 as a number that we can check. So let's maybe try 28. 28 divided by 7, is that going to be greater than or equal to 3? Let's see, 28 divided by 7, we get 4. And is that greater than or equal to 3? Yes. So H is greater than or equal to 21 works. Let's try this next problem. Here we go. 2/3 times n is less than 20. So we have 2/3 times n, so we could divide by 2/3, or we could multiply by that reciprocal of 3/2. We could do either one. So let's divide by 2/3. So we have n is less than or equal to 20 divided by 2/3. All right, 20 divided by 2/3. I don't like the looks of that. So let's say 20 times 3/2. Remember, that is our fraction operation that we can do when we're dividing by fractions. So let's rewrite this 20 as 20 over 1. So 20 times 3 is 60, and 1 times 2 is 2. So 60 divided by 2 is 30. If n is less than 30, this inequality will work. So let's try an inequality, or a number that's less than 30. Let's try maybe 27. 27 is less than 30. So 2/3 times 27 is less than 30. So 2/3 times 27 is less than 30. Let's take that 27 and put 27 over 1, so that way we can do that multiplication. 2 times 27, put that in the calculator, and we get 54. And underneath it, 3 times 1 is 3, is less than 30. So less than 30. 54 divided by 3, if somebody else put that in a calculator, I know 54 times 9, or 54 divided by 9 is 6, so 6 times 6, 18. 18, is that less than 30? Every time. Awesome. So n is less than 30 works. That solves that inequality. So let's now let's now understand our second part. This is the one that's tricky, and it's kind of interesting for inequalities. So let's get our second missing page out. You're going to want to pause the video so you can write all this down, and I want you to really understand what is being said. And so we're going to do this a little bit slower. So our last notes page for our inequalities. When you multiply or divide an inequality by the same negative number, so we're no longer positive number like positive 5 times h is equal to 25, or less than 25. This one's a negative number, so we have negative 5x is less than 45, so that's a negative number. When you multiply or divide an inequality by the same negative number, the inequality symbol must be reversed. That's a big word for the inequality to remain true. So write this down in your missing, and let's understand it. So if you need to, pause the video so you can write this down in your missing. Now let's look at this first equation. We have negative 5 times x is less than 45. So we need to undo this multiplication of negative 5, so we can undo that by dividing by negative 5. So let's put our inequality there. So we have x, and 45 divided by negative 5, that ends up being negative 9. So this concept said we needed to reverse this inequality sign. So we had a less than, so we're going to turn it into a greater than. X is greater than negative 9. Let's check two numbers. We're going to try a number that's greater than negative 9, so let's try negative 8. And then let's also try a number that's less than negative 9, so we'll try a negative 10, and see which one actually makes sense. See if this concept of reversing this inequality needs to happen. So if we have negative 5 times negative 8, so essentially a number less than negative 9, or another number greater than negative 9, if we do that, we have 40. And is 40 less than 45? Yes, it is. So that negative 8, that number greater than negative 9, worked. So that whole concept of reversing things worked. Let's now understand why it won't work. If we were to do this problem over here, so we have negative 5 times a negative 10 is less than 45. Negative 5 times negative 10, we get a positive 50 is less than 45. This doesn't make sense. 50 is not less than 45, not on any planet, not even on Pluto. So that doesn't work, that negative 10. So x is greater than negative 9. So the biggest takeaway we need to get from this is when we multiply or divide by a negative number, we need to reverse that inequality sign. Reversing that inequality sign is key. So now let's try another problem, and then we'll do a couple of practice problems. We have b divided by negative 8 is greater than or equal to negative 6. So b divided by negative 8 is greater than or equal to negative 6. What is going to undo this dividing by negative 8? Well, multiplying by negative 8. And remember, I'm carrying that that negative sign through, because if I don't, then I'm going to still have that negative on the b, and I don't want to deal with that. That's a mess. So these cancel to 1, so we just have b is greater than, b is whatever, negative 6 times negative 8 is a positive 48, and that whole concept told us that we need to flip, we need to reverse that inequality sign. So it was a greater than or equal to, and now it's a less than or equal to. b is less than or equal to positive 48. So what number is less than or equal to positive 48? Let's maybe try 40. 40 is less than or equal to positive 48. So let's put that number into this equation or inequality, and let's figure out what it actually stands for. So we have b divided by negative 8 is greater than negative 6. And if you see, I just rewrote the original inequality with a possible solution, with something that possibly could work. So 40 divided by negative 8, we get negative 5. And is negative 5 greater than or equal to negative 6? Yeah, technically it is. So let's do this on a number line. Let's really understand it. We have 0 here, 1, 2, 3, 4, 5, negative 5, and negative 6 is here. So negative 5 is closer to 0 than negative 6 is. So this answer of b is less than or equal to 48 works. Let's do a couple of practice problems. Here we go. Sorry, I hope I didn't make you too dizzy. Here we go. Here's a couple of practice problems. We have y divided by negative 4 is less than 3, and 7 is greater than or equal to negative 2f. Pause the video, do these problems. All right, so now we're back. Let's do these problems. We have y is dividing or being divided by negative 4, and that is less than 3. So dividing by negative 4. What's going to undo that division of negative 4? Multiplication of negative 4. Multiplication of negative 4. So now we simply have y is less than 3 times a negative 4, negative 12. But if you notice, did I reverse this sign? Did I reverse this? Nope, I didn't. So I really should have written this. Y is greater than negative 12 because I divided by a negative, or I multiplied by a negative number. So any number that is greater than negative 12 will work for this situation. We could try negative 8. Negative 8. So I put negative 8 in for y, and I'm rewriting that original inequality here with a negative 8. Is that less than positive 3? Negative 8 divided by negative 4. If we do that math, we get a positive 2. And is 2 less than 3? Yep, every time. So y is greater than negative 12 works. Let's now do the last one. Let's write that inequality, or write that line so we can keep everything balanced. We have negative 2f. Right there, negative 2f is essentially multiplying negative 2 and f. So we could divide by negative 2, and we're going to do that on both sides. 7 divided by a negative 2, that'll get us essentially negative 7 halves. And we're going to flip our inequality. So we have a less than or equal to instead of a greater than or equal to, and we have f. Negative 7 halves is less than or equal to f. So if we tried, essentially maybe, let's try 4. That's greater than negative 7 halves. That's an easy one. It's obviously going to be greater because it's a positive number versus a negative number. So let's rewrite this. 7 is greater than or equal to negative 2 times 4. Negative 2 times 4, that gets us a negative 8. 7 is greater than or equal to negative 8. Yep, every time. So our final answer of negative 7/2 is less than or equal to F works. Try the homework for goal 2. Starts on page 244 and some of those problems, so I hope this helps.